Beneath the shadow of the Great Sphinx, the true foundation was not stone, but biology. By isolating the genetic blueprint of 4,000-year-old charred Emmer grains, we've unlocked the high-protein secret that fueled the world's most ambitious labor force. This ancient superfood transformed humble meals into industrial-scale energy. Could the sustained power of ancient sourdough be the forgotten engine that raised Giza's monumental wonders? The question of the Sphinx's true power source begins not in quarries, but in microscopic fragments. From the workers' village ruins at the Giza Plateau, archaeologists unearthed charred Emmer grains, remnants of ancient meals. We extracted stable genomic data from these 4,000-year-old samples, employing CRISPR-based sequencing to identify specific high-protein alleles. This revealed a stark truth: these were not generic grains. They were a bioengineered fuel, specifically selected for high-intensity physical labor, providing a caloric output far beyond any modern staple. But how did this ancient genetic advantage translate into sustained energy for the colossal task of construction? The raw genetic potential of Emmer wheat was only half the equation. The transformation from grain to sustained energy lay in the unseen world of microbes. Within the porous clay of excavated bread molds, we cultured 4,500-year-old yeast strains. Comparing their metabolic profile against modern commercial yeast revealed a crucial difference. The ancient sourdough fermentation maximized nutrient bioavailability. This extended process neutralized anti-nutrients, making each loaf a highly efficient, sustainable energy source capable of powering workers through grueling 12-hour shifts. How did the ancient Egyptians engineer their bakeries to consistently produce this vital fuel? The science of ancient bread extended beyond genetics and microbiology. It was a feat of culinary engineering. We replicated the beja clay pots, using traditional Nile silt to simulate the specific heat distribution of royal bakeries. The results were astounding. A single loaf of this Emmer bread provided double the sustained energy of a standard modern meal. Its structural integrity allowed for remarkable portability and shelf life, crucial for decentralized feeding operations. This wasn't just cooking, it was a logistical masterclass, enabling thousands of masons to remain fed and productive across the vast Giza complex. But what did this mean for the actual physical demands of building a wonder? Moving 20-ton limestone blocks under the relentless Egyptian sun demanded immense, sustained energy. Our calculations mapped the precise kilojoule requirements for such a task. The bread supply chain, powered by Emmer wheat, became the primary infrastructure project enabling the carving of the Sphinx. It was a logistical marvel, designed to ensure constant caloric intake for thousands. Biomechanical analysis confirms this Emmer-based diet prevented muscle atrophy and fatigue in the workforce, allowing them to endure the punishing physical demands. This ancient dietary technology transformed human endurance into architectural legacy. Could such a profound understanding of ancient nutrition hold lessons for our own future? This ancient carbohydrate technology allowed for the first true scaling of human civilization, enabling monumental architecture on an unprecedented scale. By understanding the genetics of ancient Emmer and the processes of its transformation, we gain insight into more than just history. Sampling our final replicated loaf, we experience the exact taste and texture that fueled the builders of the ancient world. This forensic journey reveals how robust, high-nutrition crops, resilient against environmental shifts, are not a modern aspiration, but an ancient blueprint for survival. The echoes of Giza's builders resonate as a challenge to our own agricultural future.